Hello scientists, we're here to finish up the Pulleys Lab in Unit 6, so this is part 2. Remember, we're working on the same sheet as the Levers Lab. So between parts 1 and parts 2 of the video, I did a little bit of work for you here. The distance the string pulled in meters, remember up top we had 23 centimeters, but we had 4 links between the pulley and the scale to begin with, so it really only pulled 19 centimeters. And then we're subtracting what the spring scale read at the second part when we were holding the mass minus the spring scale just pulling the force of gravity pulling on the spring scale. So I showed you here my work. So the distance the string actually pulled the mass here is 19 centimeters. And 19 centimeters, if you want to convert that into meters, you divide by 100, and so you get 0.19 meters. Remember, we need meters and newtons to multiply to get work. And then to get the force, we take the force to hold the mass up with the pulley and the force of gravity pulling on the spring scale. We subtract them and we end up with 4.52 meters. We multiply newtons times meters here, and we get 0.86 joules for the amount of work done with the pulley system. And if we just look at the distance the mass was lifted and the force, we get 0.98 joules here. So 0.86 is pretty close to 0.98. They should be pretty similar, but again, I might have miscalculated here. It might have been actually 24. And this would have been 0.2, and then it would have been a little bit bigger and a little bit closer. So it's not ideal, but the lab's real world almost doesn't match ideal all of the time. So let's look at the single moving pulley here. Let's go back up and look at our numbers. For the single moving pulley, the number of links when the mass is raised, I actually stopped the video and counted here. And the number of links between the scale and the pulley here. So that's 36 and 1. So if we take 36 and we subtract 1, we get 35 centimeters here. And if we take 35 centimeters and we divide by 100, 100 centimeters in a meter, we get 0.35 meters. Now let's go up and do the force. We had 244 and 0.38, so we want to take 2.44. That's what when we were pulling on the spring scale, and this is just gravity pulling on the spring scale. So 2.44 minus 3.8. And I'll let you work that out in newtons, and then multiply meters times newtons. And here this is all worked out for you. And you can work out the amount of work done. And I'll let you do the last one all by yourself. So when we're going to look at mechanical advantage, I'm going to show you a couple pictures that might help you out here in figuring out mechanical advantage. Now remember, we talked about in the beginning of the lab we were going to use these 3 setups here, and they were going to have different mechanical advantages. So I'm going to give you a bit of a hint here, courtesy diagrams of Wikipedia. And a single fixed pulley here, you're pulling with the same force as gravity is pulling down on this mass here. So since you're pulling with the same force that gravity is pulling here and the distance is the same, there's no mechanical advantage, or the mechanical advantage is 1 on a single fixed pulley. If we go to a movable pulley here, you can see that the force of gravity on this mass here is 100 newtons, but you're only pulling up with 50. So the mechanical advantage is 2, or it halves the amount of force you have to apply, but it increases the distance. And we saw that too. You pulled 35 centimeters on the movable pulley here when in the lab. Now let's look at, this is called a gun tackle on Wikipedia, a block and tackle in some respects. Usually a block and tackle though has 2 ropes going back and forth. This is a movable and fixed pulley. This is the third kind of pulley we used. And you can see here, since you're pulling with half the force, 50 newtons, and there's 100 newtons of force on this weight here, or this mass, gravity is pulling down on the mass with 100 newtons of force, but you're only using 50 newtons to pull it up. The mechanical advantage is 2. In other words, it halves the work that you have to do. Another clue to the mechanical advantage is how far you had to pull the rope here, or the string. Here you had to pull it about as far as the mass went up. Here you had to pull it a lot further. The mass went up about 20 centimeters and you had to pull 36 centimeters up. Actually, the mass only went up 17 centimeters. It started at 3. And here you had to pull 42. So your clue here is that your distance was increased in these two, so they have some sort of mechanical advantage. So when we go down here, which type of pulleys can you use to decrease your effort force? Well, you know it's not number 1. You know it's not a single fixed pulley. You know you can use a movable pulley, or you can use a combination of single and fixed in a block and tackle kind of setup, or a gun tackle setup. Which type of pulleys are only good for changing the direction of the effort needed to move a mass? Well, I'll give you a big hint on that one. Here is the mechanical advantage of a single fixed pulley, and it really doesn't have a mechanical advantage because, see, you're pulling with the same force that gravity is pulling on the mass over here, this big block of things that you're trying to lift. So this doesn't have any mechanical advantage, but it does change the direction you're pulling. It's easier than just pulling this heavy weight straight up. You can kind of have gravity on your side pulling the rope down, or you can maybe get a team of people all on the rope together. For number 18, I'm going to let you read all about mechanical advantage right here on Wikipedia, and I will put this Wikipedia page in the notes for the YouTube. Number 19 is asking about, if you want to have less effort force, what needs to happen to the distance? And I will give you a hint. So for number 19, if you want to keep the amount of work the same, and it has to stay the same because simple machines don't decrease the amount of work, that would break the laws of physics. They decrease the amount of force you need and increase the amount of distance. You pull on the rope longer than you would if you didn't have a pulley. Thanks for watching. This is part 2 of the Pulleys Lab for Unit 6 in Physical Science Semester A. Thanks so much for watching. Bye-bye.